Section 4.3, we are going to discuss domain and range. So the first thing we need to know is that a set of ordered pairs is called a relation. So remember, our ordered pair is our point. So a set of ordered pairs is a set of points. And an example of that would be the following. So when we have a set, we are going to use these squiggly brackets to show that we have a set of something. So I'll write that over here. A set means we're going to have these squiggly brackets with some information in between. Okay, so that tells me I have a set. So our set of points is going to look like this. We could have point 2, -1, and then a point -3, 5, and a point 0, 2. So all those 3 points together, those ordered pairs, this is called a relation. I have 3 points inside of my set. So our second definition, a set of all first coordinates, which is my x value. So if I look up here, all my first coordinates are the x coordinates, and this is called my domain. Basically, the domain is just all of my x values. So if I look up here, I have, I need a squiggly bracket. If I have a set, my domain is 2, I have a -3, and I have a 0. That is my domain. And we could write that equals the domain, D. The next definition is a set of all of the coordinates of my y values. And this is called my range. So if we look up here, I'll write this in blue, range is the second value, which I have a -1, a 5, and a 2. So my example here, I could write that my range, my R, equals a -1, a 5, and a 2. These brackets around there are just telling me that's my group. That's my set of y values. So if we look at an example here, it says determine the domain and range of each below. So this tells me right here I have a set of 4 points. I have 4 ordered pairs. If I want to know the domain, all I'm going to look for are my x values. So I'm just going to write those points. I have 2, 5, a -3, and a 0. That is my domain. My range, I have a 3, a 4, a -4, and a 9. So I'm just going to write all those numbers in my set of numbers for the range. Okay, so that's how we identify the domain and range. Here, we have a very similar problem. Our information is just given to us in a different form. It's in a table. So for number 2, if I'm looking for my domain, again, all I'm writing down are my x values. So I'm just going to write down all these points in my domain. I have -3, 0, 2, 5, and -1. Those are my domain points. And then my range, I'm going to do the same thing. I know my range is my y values, so I'm going to look right here at all my y points. So I'm just going to write down all those. I have -1, 0, -3, 6, and -1. Okay? Now here for number 3, I still need to find the same pieces of information. I want to know what all of my x values are and what all of my y values are. So I can do that either by looking at my points here, or I could rewrite my points on the side. So if I have this point here, my x value would be 1, 2, and I'm going up 1. So that's my first point. If I have this point here, I need to go over 1, 2, 3 on my x-axis and down 2 on the y. This point here, I am staying right at 0 for my x. I'm not moving left or right at all. And then I'm going down 1. This point on my x-axis, I need to go over -1. And I'm not going up at all. I'm staying right at 0 for my y value. And my last point, going over 1, 2, so that's x is -2. And then I'm going up 1, 2, so +2 for my y. So now I have all my points here. I can write my domain, which is all my x values. And so when I write these down in my domain, I actually want to put them in order from smallest to largest. So if I look for my smallest x value, my smallest one is the most negative, which is a -2. And then after -2, I have -1, 0. And then my next smallest is a 2. And then 3 is my biggest x value. So that is my domain. And my range is going to be all of my y values. Again, I'm going to put those in order from smallest to biggest. So I have my smallest range is a -2, then I have a -1, a 0, a 1, and a 2. So that is how I can find my domain and my range from a graph. For these next problems, I actually want you to just cross off number 4. We're going to skip that one for now. And then I want you to practice number 5 on your own. So practice that now, pause the video, and then raise your hand if you have questions if you're trying to figure out how to do it. Okay, so now that you've tried the problem, you can pause the video again, check your answers. This is what you should have gotten for number 5. On this next note sheet, we are going to do some more practice with domain and range by looking at our graph. So number 1 looks similar to what we've done before. We have we have 5 points graphed for us. And if we write those points to the side, we have -1, 2 for my x. We're looking at this point right here. -2 for my x and 2 for my y. And then this point we have a -1 for my x and -1 for y. For this point here, we are starting at 0, 0. We do not move left or right, so our x is 0. Go up 1. For this point, we're going to go over a +1 in my x direction, 0 in my y, and then my last point here, I have 1, 2, 3 in the x direction, and up 2 in my y direction. So then I can write my domain. My domain here, I have a -2, -1, 0, 1, and 3. Those are all my x values right here. And my y values, I know that, oops. Fix that. My y values are all on this side, and that is going to make up my range. So my range is 2, -1, 1, 0, and 2. So that is what we were practicing before. Now for number 2, it gets a little trickier because now we don't have a set of points. Now we have a curved line. So our rule for this, when we're graphing, we're going to put it over here, our rule. When we write our domain and range from a graph of a curved line, we are going to write from dot to dot. So I'm going to write our rule here and then I'll explain it a little bit. If we have our domain is equal to some number, which is going to be less than or equal to x, less than or equal to some other number. And so this right here is going to be where our point starts. And this right here is where are going to be our point stops. So if we look over here on our graph, at our first point right here, this is where our line starts. So our domain here is going to be a -1, 2, 3, 4, or -4 in my x direction. And I'm going to fill in less than or equal to x, less than or equal to, and then where my point stops. So I see my line goes all the way down here, and this is where that point stops. So I have a 0. Sorry, not a 0. That's not the origin. Our point here is a -1. So that is our x, our domain, for our curve there. Our range is going to be very similar, but instead of an x, we're going to put a y because our range is our y values. So again, we're going to have where our point starts right here and where our point stops right here. So to find those points for our y where they start and stop, our y-axis is right here. So we need to find our smallest y value and our biggest y value. So we have the top of our function up here is right here at this line. We have a y equals 2. And then we have a point here, but this point here, 0, is not our smallest y. We have this point. We look across, that's at -2. So this is our smallest y, and this is our biggest y. So this is where our line starts for the y at -2. That's our smallest y value. And we fill in less than or equal to y, less than or equal to. Our biggest number for y we have is 2. Okay, so let's try another one. Number 3, we're doing the same thing. So we have our lines connected here, and for our domain, we are going to have our number is less than or equal to x is less than or equal to a number. So you can fill these in right away without even looking at our graph. We know that we are just going to fill in these missing pieces of information. So for our x value, our x-axis is right here. And if we look, we want to find where our line starts. So our smallest x value right here, which we count over, we have -1, 2, 3. And then we want to go to our largest x value, which we have at 2. So now I can plug in my numbers. I have a -3 and a 2. For my range, I'm going to look at my y. I want to find my smallest y and my biggest y. So if I start at the bottom and I go up, this is where I first hit my line, and that is at -2. And my biggest y, I look over here, this is the very top of my graph, go up 2. So my range for y is -2, 2. Okay, let's look at number 4. I'm going to fill in my blanks here. I have my x is my range and my y is, my x is my domain, my y is my range. So I need to find those numbers now. So I have my line right here, my x, my smallest x is going to hit right here. I've got -1, 2, 3. And then I go along my x, and this is my last point for x at 2. So I can fill those in, -3 and 2. And then my range here, I only have one point where y is going to hit. Y is always on this line right here. This line right here is at a y equals 1. So this is saying that no matter where my point on my line is, it is always going to be 1. So that means I can actually erase this right here. My range is always just going to be 1. And I can write that as y equals 1. Always. For this line, my range will always be equal to 1. Okay, so I want you to try these next two, 5 and 6, and then, so you can pause the video and try them, and then you can check your answers when you've tried them. Okay, so this is what you should have gotten for your answers. And once you are finished with that, you're going to go ahead and try some of the problems on the worksheet. Okay, the last part of 4.3, we are going to go over a little bit more about domain and range with tables. And our first definition up here is the set of all solutions of an equation is called the solution set. And remember that a solution is a true answer to an equation. So if in number 1 it says to solve y equals x if the domain is -2, -1, 0, 2. So if the domain, remember domain is x, if our x values are these 4 options, we're going to write those here. Domain is -2, -1, 0, and 2. We're going to take those x values and plug them into our original equation and see what we would get for our y. So we have our x values here, y values here, and our equation is y equals 2x. So when I plug in these numbers, I have y equals 2 times -2. I'm plugging in my domain, and when I multiply that out, I have 2 times -2, which gives me -4. So I'm going to do that for each number in my domain. Y equals 2 times -1, and 2 times -1 gives me -2. Y equals 2 times, I have 0. 2 times 0 gives me 0. And then 2 times 2, which gives me 4. So now I have all my range points. Now that I have my domain and my range, I can graph my solution set. And when I graph my solution set, remember a solution set looks like this. We have a bunch of ordered pairs. So we have my domain -2 and -4 go together. Then I have a -1 and a -2 as an ordered pair. I have 0 and 0. And then I have 2 and 4. And it's important that you keep these lined up. So the 2 and the 4 have to go together. Same with the 0 and the 0. Those numbers go together in this equation. So this is my solution set, and it's asking me to graph these points. So when I do that, I have -2, 4, 1, 2, 1, 2, 3, 4. -1, -2, 0, 0, and 1, 2, 1, 2, 3, 4. So these are my points, and I can connect them all together with a line. Imagine that's a straight line I connected them through. Okay, so let's try number 2. Number 2 says find the range if we have our equation y equals -3x plus 1. If the domain is -2, -1, 0, and 1. Those are all my x points. And then graph it on the plane again. So I'm going to write my equation here so I can plug in all of my x values. And the reason I'm plugging in for x is because they gave me my domain, which are my x values. So I can take my x values, plug them in here. I have a -2, a -1, a 0, and a 1. Got all those numbers right here for my domain. So now I can solve them. I can figure out -3 times -2 gives me 6, plus 1 is 7. And you can type these into your calculator too. You have -3 times -1 is 3, plus 1 is 4. -3 times 0 is 0, plus 1 is 1. And -3 times 1 is -3, plus 1 gives me -2. So now I have all my domain and my range values. I can write my solution set, and I have -2, 7. So these two numbers go together here. I have -1, 4. Right here, -1, 4. And I have a 0 and a 1. And then I have 1, -2. Now you can skip this part down here, writing the solution set at the bottom, if you can see your points above with your domain and range values. But writing it down here helps you see your points all together. So our first point, we have -2, 7. Which -2, 7 is a little off our graph up here. Then we have -1, 4, 0, 1, and 1, -2. Again, we can connect those all together with a straight line. Okay, so now we have number 3, and I'm going to have you try this one on your own. So you can draw the table like you had above and try and figure out what the range is and graph your points. Okay, this is what you should have gotten for number 3. For our last part here, to determine if an ordered pair is a solution to an equation, you're going to follow these 3 steps here. our first step is to substitute for x and y in the equation using the ordered pair you're given. So our first value is our x, and our second value is our y. Then you're going to simplify, and if both sides of the equal sign are the same, then it's a solution. If they're different, then it's not a solution. So if we look at number 4 here, it says which of the ordered pairs are a solution for y equals negative x plus 3. So if we try our first one, if we plug in 0 for x and 0 for y, we are going to get 0 equals 0 plus 3. When we simplify that, we get 0 equals 3. This is not true, false, so it's not going to be choice A. For letter B, our y here is 4, and our x is 1. So when we plug this in, we have our y is 4 equals, now we have that negative sign, negative x, which is a negative 1, plus 3. Simplify this, negative 1 plus 3 gives me 2. 4 does not equal 2, so this is false again, and this is not our answer. C, we have a 2 and a 1. So our x value is 2, so we're going to have a negative 2 plus 3 on this side, and our y is 1, so we plug in a 1 here. Now we have 1 equals negative 2 plus 3 gives me 1. 1 equals 1, so that is true. That means this one is going to be our answer. And if we look at D, just to double check, make sure we didn't make a mistake, if we plug in our 2 here for y, and we have a negative, we got to plug in this negative 1 for x, and add 3. We have a negative times a negative, which is a positive, so we have 1 plus 3, and then we get 2 equals 4, which is false. So C is our answer. Okay, so try number 5 and determine if this point is a solution. And this is what you should have gotten for number 5.